Okay, so quickly going through these answers. In number 1, degree 2. In number 2, degree 3. In number 3, that's degree 4. 4 is degree 1. 5 is degree 3, or 4, sorry, because you add the 1 and the 3 together. Number 6 is degree 4. And then number 7, don't fall for the trap, that is 3 squared, which is really 9. So you get 9r to the 4th, so the degree in 7 is 4, not 6. And number 8, the degree is 8. And number 9, we look for the highest and then add them together. So the first term is degree 3, the second term is 4, and the last term 3. So the highest degree is 4. And then in 10, you have 4, 3, and 5. So number 10 is degree 5. To arrange the terms in ascending order according to powers of x, you're going to pick the highest powered x to start with and rearrange them down. So that's x to the 4th plus 3x cubed plus 2x squared plus 5. And then 2x squared plus 3x plus 1. 3x squared plus 5x minus 6. X cubed plus 9x squared plus x plus 2. And then again over here, 3x cubed minus x squared plus 4x minus 3. And in 16, x to the 4th minus x cubed plus x squared plus a negative 2x. And then in 17, x cubed plus 6x squared plus 12x plus 6. 18 is the first one where you have mixed variables. You want to still take it in terms of x, so you start with negative 15 x cubed, then negative r squared x squared, then 7r5x, and then end with 21r to the 4th. So you still look for the highest powered x and make your way down. Well, the direction said in terms, like, so since the direction said with the powers of x, you ignore alphabetical. But yes, if it was x, y, z and the directions didn't say anything, you would go with x. And then if it was a, b, c, you'd go with a. But yes. Okay, and then same with down here, arrange the terms of each so that they are in descending order. So now that's the opposite. You're going to start low and get big. So you'd go 4x, negative 3x squared plus 5x cubed. Here you would start with your constant again, so it would be exactly in the order that it is given. And then here you'd go 27 negative x plus x squared plus 3x cubed. Negative 17 positive x squared positive 3x cubed. Negative 1 positive x cubed. 64 minus x plus x squared plus 3x cubed. And then 25 plus x plus a negative x cubed. And here again, we want to go with descent to x. So that would be like 5p, because there's no x, then px, then p cubed x squared, and then 1/3 px cubed. On the back, we were adding and subtracting polynomials. So those answers are as follows. Okay, so there was 1 through 6. Here is 7 through 12. Okay, and then 11 through 16. And then moving on to the homework from the section in the book. So we picked up with the second part. You guys had to do 30 through 50. So here is the top of that. And then again, if you need to see any of these worked out, after you go through, look and kind of try to look for any errors or mistakes, I can do any problem you want. It's just easier to give you the answers so that you don't get lost in some of the work. Okay, and then 34 to 36, or 37 rather. Okay, am I still checking those? All right. So 38 was actually one of the first ones that was a little bit more complicated. So I did work through 38, kind of showing that when you have 3 terms being multiplied together, you want to do the first 2 terms, simplify that, then distribute and multiply out through the last 2 terms. So in 39, you would want to do something similar. You'd start with the first 2 terms, so you had 2a squared plus 3ab plus 2ab plus 3b squared, and that 2x minus y sort of tags along. you want to group together the 3ab and 2ab to get 2a squared plus 5ab plus 3b squared times 2x minus y. And then you could use either the box or the first, middle, last technique and distribute and then combine like terms as well. So 2 times 2 got you 4a squared x plus 10abx plus 6b squared x. And then you would go through and do it with the y's. So you would have minus 2a squared y, minus 5ab y, and minus 3b squared y. Now since x and y have no like terms with the a's and b's, this right here is going to be your final answer. There are no like terms once you distribute and multiply in those x and y's. Okay, number 40 for part A, Connor should have had 12x, and for part B, it was 11y. So just 12x and 11y. Okay, 41. After you distributed the 4 and then cleaned everything up, your final answer was y to the 4th, 81x to the 4th. And 42 was 27, b to the 6th, a to the 9th. Okay, 43, x to the 6th over 16y to the 14th. And then 44, a to the 24, all over 125, b to the 24. In 45, first you wanted to take in the negative 2. Then you wanted to multiply, or in this case, subtract the a's and the b's, so that in 45, your final answer was b. So I heard a lot of what's, so here's what happens. You have a squared b cubed. That's being multiplied by a to the negative 2, b to the negative 2. So remember that if you're multiplying two variables with the same bases, you add their exponents. So you have a2 minus 2, b cubed minus 2. So 2 minus 2 is 0. Anything to the 0 power is not 0, but 1. So that a to the 0 became a 1 times b. Okay, and then in 46, you got 36, x7, y4. With the top two? Sure. All right, so similar idea in 43 to what we did in 45. You're going to take that negative 2 and distribute it to every part. So you have 4 to the negative 2. The negative 2 to the negative 2 gets multiplied. So a negative times a negative gives a positive 4. So you get x to the 4th. And then here you get y to the negative 6. And then that negative 2 also has to distribute to the bottom terms. So you get x to the negative 2, y to the positive 8. And then our rule is that if you have a negative exponent, you drop it to the bottom. So the 4 squared drops to the bottom as the 16. And then the rule for the variables is top minus bottom. So the x's are like x to the 4 minus a minus 2. So two negatives turn to a positive. So that's how we get x to the 6. And then similarly with the y's, it would be negative 6 minus 8. So negative 6 and a negative 8 give a negative 14. So it drops to the bottom as a positive 14. Does that help, Spencer? I know you asked and Colleen too. Yeah?
I just multiplied, instead of taking that down to the bottom, I just squared it by that negative and plugged it in the calculator and got that decimal percentage.
Okay, so you said you plugged it into your calculator. You mean like the 4 to the negative 2 in your calculator? And it came out as a decimal.
Yeah.
So instead of 1/16, you probably had whatever 1/16. 0. It should be 0.0625. Yes. Yeah, 0.0625. Yeah. So is that what got you in number 44 then also? Okay, so like it would be like 1 over 1/25. So maybe you had 0.008. Okay. So those aren't wrong, but those of you that are kind of starting to prep and think about taking your SATs, they are never going to give you on the SATs a decimal with a fraction. So do you guys know how on your calculator, if this was a calculator question, just to get this back to a fraction, you're going to hit that math key right here, and then you're going to hit enter, enter, and what it's going to do is turn that decimal back into a fraction. Just because, like, if it was on the SATs or, like, on, I don't know what others, maybe, like, if you're taking an AP test for math or for physics, they're never going to give you a decimal mixed into a fraction. Does that make sense? Thanks. You ma'amed me, though. That makes me feel a little old. All right. 47. We have 2/5. So again, maybe you have your 2/5, you have 0.4. And then it's CD4. And then 48, you should have a negative 1/3 G to the 5th, H to the 9th. So when I look at something like 48, I would clean up the top, getting the G's and the H's together first, then clean it up with the bottom. So I would probably have turned my top to negative 10, G, and I would have added the 6 and the 2 to get 8, added the 9 and the 3 to get 12, and then looked at each of them stacked individually. And then the rule of thumb is that if you have constants with zeros at the end, you can actually just cancel those zeros out. So like if you ever had 500 over 20, that actually reduces, you can actually just cancel the zeros out at the end of that. And 500 over 20 is equivalent to 50 over 2, which is the same as 25. So just instead of trying to do 500 over 20, etc. Okay? And then 49, simplified, you should have gotten 1/2 x6 y cubed. And then 50, also negative 1/3 n cubed p squared. So overall, how do we feel about section 1? Not too terrible?
I feel great.
Well, section 2 isn't too bad to start either. We're going to pick up with dividing. So we are dividing polynomials now by polynomials. So when we do polynomial division, what we are going to do is actually something very similar, but now we're going to be expanding our polynomial division so that we have multiple parts being divided amongst them. So the first thing we're going to look at is dividing a polynomial by a monomial. So we're going to look at a polynomial by a monomial. So in order to divide multiples by a single term, we rewrite it so that that polynomial term is sort of underneath each of those individually. So you're going to take that one term and rewrite it under each term. So you're going to simplify each of those exactly like we simplified in section 1. So that you get a final answer of, 2RS plus S minus 3R. Okay, and we're going to do the same thing in number 2. Now, if you can do these sort of without rewriting them, but simply imagining that 3AB under each term, then you can simplify without showing me this step in the middle. So again, you guys are, more advanced math students. If you don't need to write down this step, that is perfectly okay. Okay, and then lastly in number 3, you're going to take that 12x squared y minus 3x and also divide it by 3x, giving you 4xy minus 1. So, unfortunately, Chapter 6, Section 2 does not stay this simple. What we're going to do is start dividing polynomials by binomials. So instead of just having a singular term down in that denominator, we're going to have 2 terms in our denominator. And there are 2 techniques we're going to learn this week in order to divide polynomials using binomials. The first technique we're going to learn is long division. The reason we learn long division first is because long division works for any polynomial divided by a binomial or a polynomial, meaning it could also be divided by a trinomial, etc. Tomorrow's technique is going to be one of those techniques that is restricted to certain cases. So long division uses a technique that we learned way back in 3rd grade, which was actual long division. So what you're going to do is subtract and bring down those numbers the same way you did in 3rd grade. Okay? So if you think back to 3rd grade, you had the top number, and then it was divided by, let's say, a bottom number. So, and maybe we'll make this 84 instead of 54. So what you had to do was say, okay, that's really like 24 into 84. And you looked at that and you said, okay, how many times does 24 go into 84? And the first thing you would do is say 3, because 24 times 3 was 72. So you put a 3 there, you multiply 24 times 3 and got 72. And then you said 84 minus 72 was 12. And we said, oh, 24 can't go into 12. So 12 was our remainder, and your remainder got rewritten over the original divisor. So 84 divided by 24 was 3 and 12/24, or 3.5. We're going to do something similar to that, but with polynomials and binomials. So we're going to take the bottom divisor, and you're going to put it on the outside of the division bar. The numerator goes inside the division bar. That's called the dividend, because this is like the den, dividend. It's the den of the math. And then what you're going to do is say, okay, what do I have to multiply x by to get x squared? So to go from x to x squared, I need x. So you put an x up top. And then just like in long division back in the day, you're going to subtract the next line. And that next line comes from taking that x up top in red times the x over here. So you get x times x is x squared. X times 3 is 3x. But again, you're subtracting that line. So it's minus x squared, and then that negative also distributes to the 3x. X squared minus x squared is 0. You should always be able to zero out that first term. Then you add down, so 5x and 3x is negative 8x. And you bring down the next part of the term. So you bring down that negative 24. And then we do the same thing again. What do I need to multiply x by to get negative 8x? So I need to multiply by negative 8. So negative 8 times x is negative 8x. Negative 8 times 3 is negative 24. But remember that we are subtracting that line. So what that means is that negative 8x becomes a positive, and that negative 24 also becomes a positive. So 8x and negative 8x is 0. Negative 24 and positive 24 is 0. So if I get a remainder of zeros, I'm super happy, because what that tells me is that x plus 3 is a factor of x squared minus 5x minus 24. So what that means is that x squared minus 5x minus 24 could have factored into x plus 3x minus 8 divided by x plus 3. So the x plus 3's technically cancel when you get that remainder of 0. Tells you that it factors and cancels. And your final answer is x minus 8. So the answer to x squared minus 5x minus 24 all over x plus 3 is x minus 8. Okay, let's look at the next one. We have h cubed minus 11h plus 28 to divide that by h minus 4. If you have a power of negative 1, we know that that can be rewritten in my denominator. So in this case, this is like division, not actually multiplication. So once again, set it up. You have h cubed. Now, what you should notice is this goes cubed to h. We are missing the squared term. If you are missing a power, you are going to put in a 0 placeholder. So 0 times h squared is 0. So writing in that placeholder does not change anything about the problem. So this becomes h cubed plus 0h squared minus 11h plus 28. And then we're going to do our long division again. So we ask ourselves, what do I need to multiply h by to get h cubed? And the answer is h squared. H squared times h is h cubed. H squared times negative 4 is negative 4h squared. Here's why that 0 placeholder comes into play. It allows us then to continue to stack like terms. And then we're going to subtract this. So we're going to just simply change those signs. You get 0 and then 4h squared. And then you bring down the next term. And we re-ask ourselves, what do you multiply h by to get 4h squared? And the answer is 4h. So again, our goal is to always cancel those first terms. So you have 4h squared minus 16h. Change our signs. We get 0 and then 5h. Bring down our 28. What do you have to multiply h by to get 5h? The answer is 5. So then you have 5h minus 20. Change your signs. And we get 0, so we know we've done it correctly. But now I have plus 48. So if I get a remainder, that tells me h minus 4 is not a factor of the original problem. And that 48 gets tagged on to the end as a remainder over the divisor. So our final answer this time is h squared plus 4h plus 5 plus 48 over h minus 4. Okay, and let's look at one last problem. So we have 4x squared plus 23x minus 16 times x plus 5. So we fall into a trap sometimes that when we're learning a lesson, and that lesson is division, that we tend to ignore what's actually happening in the problem. And in this case, these are being multiplied together, not divided. So we're not setting up long division. We're actually distributing and combining like terms. So you just want to look out for mixed problem sets. So this would be 4x cubed plus 23x squared minus 16x. And then distributing that 5, you get plus 20x squared. And then plus 23 times 5, which is 115x, minus 5 times 16, or 80. Combining like terms, you get 4x cubed plus 43x squared, and then 115x minus 16 is 99x minus 80. So your homework is that next page. You are doing 12 to 19 on the front and 26 to 31 on the back.